Section 5.3 again. This time we're going to look at that other method for factoring these trinomials. These are trinomials of the form ax squared plus bx plus c, where that leading coefficient a is not 1. And this is called the AC method. In your textbook, she refers to this as factor by grouping, and that's certainly a component of it. But most of the time we hear this term, the AC method, and the reason for that is because we are going to look for two numbers. We're going to look for two numbers. Now, when it was just a trinomial where that leading coefficient on the square term was 1, we looked for two numbers whose product was this number at the end and whose sum was that coefficient in the middle. That's section 5.2. The AC method, because this is not simply a 1 on the front, this by itself won't work. What we were doing exactly in 5.2. So we're going to be looking for two numbers. We're going to be looking for two numbers whose product is A times C. We're looking for two numbers whose product is AC, hence the name. Now the sum is the same, and whose sum is that coefficient on that middle term. And then we've got more to do in this process, which will lead us to a factor by grouping. So let's go ahead and grab one of the homework problems. I'm going to work a few of these for you. Let's grab number 26. Each of these we will have already done last time, except there's one additional one I want to show you here at the end. But number 26 for now. And let's see how this works. So, I'm looking for two numbers. I'm looking for two numbers whose product is A times C, 5 times 4. I'm looking for two numbers whose product is 20. And at the same time, those two numbers have a sum of 12. And can you think of any two numbers that would do that? Well, 10 and 2. Of course, you can always go down the list. Anytime you get stuck, you can list your factor pairs. Is it 1 and 20? Those don't add up to 12. Does 2 go into 20? Yes, 10 times. Those do add up to 12. So those are the two numbers that I'm looking for. Now the thing is, what are we going to do with those two numbers, this 2 and that 10? We're going to use them to split apart the middle term. And so we have our 5z squared, and now I'm going to rewrite this middle term as plus 2, signs belong to their terms, signs belong to their coefficients, that's a positive 2, plus 2z and plus 10z. And at the end, I've got my plus 4. Notice I haven't changed the value of the problem. I have not changed the value of the problem. If I combine like terms, I'm back where I started. But now I have a polynomial of 4 terms, and we know that we can treat that as a factor by grouping. Group the first pair. Group the second pair. Of course, if that were a negative in the middle, we'd have to keep the negative with the term. Out of the first pair, and this is again a section 5.1 at the end, factor by grouping. Out of the first pair, I can factor out a z, which will leave 5z plus 2. Out of the second pair, the greatest common factor there is 2. So plus, factor out a 2, which leaves, if I pull out a 2, that's going to leave me 5z and plus 2. Finish your factor by grouping, by factoring out this common binomial factor of 5z plus 2, and it leaves z plus 2. And there's the same answer that we got last time by trial and error, by simply unfoiling. And what we're really doing is we are breaking this trinomial back apart into the 4 terms that would have come from foiling this answer. Foil this answer back out. What do you have? The first, 5z squared, right there. The outside, plus 10z, right there. The inside, plus 2z, right there. And product of the last, 2 times 2 is 4, right there. Combine like terms, that's how you'd multiply this. That's how you'd start with your binomials and multiply it to get that trinomial. By looking for these 2 numbers, I'm finding the original coefficients that would have been used if I were foiling this answer together to get the trinomial. And so what am I doing? I am undistributing, undistributing, and undistributing again, because what is FOIL? Where does it come from? It comes from distributing, distributing, and distributing again. Once I find those 2 numbers, these 4 terms are guaranteed to factor by grouping. Let's do another one. Let's grab number 34. Again, you can look back and see how we did that by trial and error. And the advantage of the AC method is that it's a guaranteed method. The disadvantage is it can be more time consuming than trial and error, than unfoil. Because once you get enough practice, trial and error becomes very quick most often. But if you get stuck, it's nice to have a plan to fall back on. And this AC method is that plan. This AC method will find exactly what I need to be able to get this factored. Or show me that it cannot be factored. We'll see at least one of those. So, if I'm going to use the AC method, I start off by saying, I'm looking for 2 numbers. Now remember what I told you last time. I forget to mention, get that greatest common factor out first. There's no greatest common factor to factor out here. But always, always, always look for a greatest common factor first. We don't have anything common but 1, so we're ready to get started factoring this trinomial. I'm looking for 2 numbers whose product is A times C, whose product is 9 times 8, 72, and whose sum is negative 18. What does that tell me about the 2 numbers I'm looking for? Well, the same thing that these signs tell me. That they will be of the same sign, and they'll both be negative. Has to be. That's how you get a positive product, and at the same time a negative sum. It's got to be a couple of negative numbers. And if it's not obvious what 2 numbers I'm looking for, we can always go down the list. We start with 1 and 72, but we know this time they're both negative. Is it negative 1 and negative 72? Do those add up to negative 18? No. Does 2 go into 72? Yes, 36 times. Does that add up to negative 18? No. Does 3 go into 36? Yeah, I'm sorry, does 3 go into 72? Yes, it does, 24 times. Does that add up to negative 18? No. Does 4 go into 72? Yes, it does, and I can see that right here. 2 went in and left an even number behind. That means there's an extra 2 hanging out to make a 4 with the 2 I've already pulled out. Double the 2 to get a 4, take half of the 36 to get an 18. Do these add up to give you negative 18? Nope. All right. How about 5? Does 5 go into 32? No. Does 6 go into 30? I keep saying the wrong number. Does 5 go into 72? No. Does 6 go into 72? Yes, it does, because 2 and 3 both go. So 6 has to. Double the 3 to get a 6. You can cut that 24 in half, and that's a 12. And do these add up to negative 18? Yes, they do. So there are the 2 numbers I'm looking for. Already, this guarantees me that this will factor. Because I was able to find the two numbers, I know that this is factorable, that it's not prime. I use these two numbers to split apart the middle term. Now, look how long it took us just to get that list, and we still need to go back and factor by grouping. If I'm completely stuck, this is great. But in the time it took me to do this, I may have already had this factored by trial and error. I want you to know both methods because they each have their advantages. We use our two numbers to split up that middle term. We've got our 9p squared up front, and then splitting that negative 18p into negative 6p and minus 12p is going to give us 4 terms here at the end when we pop on that plus 8. So we looked for two numbers, we found those two numbers, we used it to rip apart that middle term. We now have 4 terms and we can factor by grouping. Group the first pair, and once you make this plus a negative 12, keep that negative with the 12, you can group the second pair. Out of the first pair, greatest common factor is 3p. Factor out of 3p to leave 3p minus 2. Out of the second pair, greatest common factor here is 4. But do I want to factor out a positive 4? Look at your signs. If I factor out a positive 4, it's going to leave me a negative 3p and a plus 2. I'm trying to get it to match this. So if I look ahead, I see I really need to factor out a negative 4. Factoring out a negative 4 from negative 12p leaves positive 3p. Pulling a negative 4 out of a positive 8 leaves minus 2. My two binomial factors match, which if you were able to find the two numbers you were looking for, this is guaranteed to factor by grouping. We can factor out that 3p minus 2, leaving 3p minus 4. And that's factored. All right, let me have you try the next one. Let's do number 36, another one that we did last time by trial and error. I want to see how this works using the AC method and this idea of using factor by grouping to get these done. Now, let me help you get started because we haven't worked one together just yet with a negative on the third term yet. So let me get you started on looking for your two numbers. You're going to say, I'm looking for two numbers whose product is 10 times negative 6, whose product is negative 60, and whose sum is negative 11. And if you can think of two numbers right off that do that, you're looking for two numbers that multiply to 60, and when you subtract them, right, because they're going to be opposite in sign, when you subtract them, they give you an 11. If you need to go down the list, you're going to start with 1 and 60 itself. But what do these tell me? This tells me my signs are opposite, and what did this tell me last time? That of my outside and my inside, which is what these numbers are. They're the outside and inside of FOIL. This tells me that the larger of my two numbers needs to be negative. And of course, that's how I would get a negative product and a negative sum. Is it 1 and negative 60? No. I'll let you keep going. And come on back and compare answers with me when you've got this one done. Continuing the search for these two numbers, we'll say, does 2 go into 60? Yes. 30 times, but that doesn't add up to negative 11. Does 3 go into 60? Yes. 20 times. That adds up to negative 17, not what we're after. Does 4 go into 60? Of course it does, because 2 went in and left an even number behind. So 4 goes in. If I doubled the 2 to get a 4, I can take half the 30, and that's a 15. 4 and negative 15, are those the two numbers that I'm looking for? 4 plus negative 15 is negative 11. So here are my two numbers. We're going to use those two numbers to split apart this middle term. Now, one thing I like to do, if I have opposite signs, I like to put my negative up front. When I split apart that middle term, I like to put my minus 15 here and my plus 4 there, because when I go to factor by grouping, I don't have to worry about a negative getting chopped off. I don't have to worry about making two marks. And it will work either way. If you have the 4 up front and the 15 for your third term here, that's fine. Let's see how we finish off. We should get the same answer. It does not matter what order you put these two terms in. We should all get the same answer at the bottom. The way I've got it, I'm going to group the first pair, group the second pair without worrying about a negative. In the previous problem, we had no choice. Our signs were the same. They were both negative. So we got stuck with a negative in the middle. This time I had a choice, and I like that plus in the middle better. Out of the first pair, the way I've got it set up, I can factor out a 5 along with an x. And that will leave behind a 2x and minus 3. Out of my second pair, I can factor out a 2. Factoring out a 2 leaves 2x and minus 3. Factor out that common binomial factor of 2x minus 3, and we have 5x plus 2. Did you get those two factors? If you did, you're in business. If you didn't, let me show you the other way to do this. Let me put my 4 up front and my 15 in the back this time, because that might be the way some of you did this, or perhaps even most of you. Let's use my two numbers to split apart my middle term. And there's nothing wrong with using my plus 4 first and then my minus 15. Minus 6 at the end. Now factor by grouping. Group the first pair. And here I've got to keep that negative with the 15. That's the only reason I put my 4 in that third position, was just to get out of doing that. It's no big deal. Out of the first pair, this time I can factor out a 2 along with an x, which leaves 5x plus 2. Out of the second pair, greatest common factor is 3. Is 3 what I want to factor out? I'm trying to get my two binomial factors to match. And so it's not the 3 I want to factor out, it's a negative 3. Factor out that negative 3 and it will leave positive 5x and plus 2. And I do have binomial factors that match. Factor out that 5x plus 2, leaving 2x minus 3. Same answer we got before. Doesn't have to be in the same order. Multiplication is commutative. How'd you do? Let's look at number 38. And let's remember last time. In fact, let me rework this using trial and error, because there's something I want to point out. I want to show you what this AC method is doing for us. So we said no greatest common factor to factor out. If this factors, it will factor as a pair of binomials. It has to start with 2t and t. There's no other way for that 2t squared to fall apart. Signs are the same. They're both minus. Then I've got to figure out how this 15 is going to fall apart. And we said, well, it could be 1 and 15, 15 and 1, 3 and 5, 5 and 3. And we started trying them. And I want to pay attention to these pairs of numbers that we get down here for my outside and inside. Let's try a 1 and a 15. And this is the one where I said, oh no, that's definitely not going to work, because what did we get? In the middle, a minus t, on the outside minus 30t. That's huge compared to what I'm after. That gives me minus 31 in the middle. I want you to kind of notice these coefficients, a negative 1 and a negative 30. Okay, well, that didn't work, so we tried something else. How about the 15 there and the 1 over there? And then we checked. Inside gave us minus 15t, the outside gave us minus 2t, a total of negative 17t. That didn't work. Notice those two numbers, the negative 15 and the negative 2. So at some point we also tried the 3 and the 5. We tried the 3 and the 5. And we checked. It gave me a negative 3t on the inside and a minus 10t on the outside. That adds up to negative 13t. That didn't work. And we tried one more time. And if it doesn't work this way, it doesn't work at all, because I've run out of factor pairs and ways to place them. Minus 5t, minus 6t. That does not add up to negative 14t. At that point we said, we have exhausted all possibilities. And this is prime. Now the issue with that is sometimes it is hard to convince yourself that you have gone through every single possibility that there is. This is a short list of numbers, and the 2 had to be 2 and 1. When both of these numbers need guessed at, how they fall apart, and they have more factors, so they have more factor pairs, it gets pretty messy. If you suspect that the trinomial you have might be prime, I strongly recommend checking using the AC method. It's not always easy to convince yourself that you've tried every possibility and didn't miss anything. The AC method on this one here, on number 38, we would say I'm looking for a product of A times C. I'm looking for two numbers whose product is 30. And I'm looking for a sum of negative 14. What two numbers will do that? And so we start going down the list. We start with 1 and the number itself, knowing that my numbers will be of the same sign. In fact, they'll both be negative. Do those add up to negative 14? No. Do those two numbers look familiar? Does 2 go into 30? Yes, 15 times. Do they add up to negative 14? No. Does that pair look familiar? Does 3 go into 30? Yes, 10 times. Doesn't add up to negative 14. That pair also looks familiar. 4 doesn't go into 30. 5 does 6 times. That doesn't add up to negative 14. Does 6 go into 30? Yes, but I've already discovered that in my list. We've made the U-turn at the bottom. These are the only pairs of numbers that are factor pairs of 30, both being negative, so my sum would be negative. I've run out of factor pairs for 30. There are no two numbers whose product is 30, whose sum is negative 14. Done. This must be prime. The AC method is a very powerful tool for showing that a trinomial is prime. And what it does is it cranks out all these possibilities for us. These were all the failed tests, weren't they? The 1 and the 30 added up to a negative 31. We threw that out. We saw these when I tried, 15 and 1. And I checked my outside on my inside. Then I started trying the 3 and the 5. And I got these last two sets, these last two pairs of numbers. So these are the coefficients from my trial and error method for the outside and the inside. And if you can't find a pair of numbers that meets these conditions, then you're never going to trial and error your way to get that factored, meaning it's got to be prime. Now there is one more problem that did catch my attention. We did not do this last time, but I want to point it out. And I'm kind of surprised it's in this section. Number 56 and its companion problem, number 55. Let's look at number 56. This is actually a 5.2 type problem, isn't it? Because the leading coefficient is 1. So if this factors, it will factor as a pair of binomials, each starting with x. My signs are opposite. And in fact, the larger the two numbers I'm looking for will be negative. I'm looking for two numbers. I'm looking for two numbers whose product is -7 and whose sum is -8. This is section 5.2. There's no factor by grouping because that leading coefficient is 1. Can you think of any two numbers that will do that? Well, the numbers have to be opposite in sign, so is it 1 and 7? With the larger the two numbers being negative? Nope. And 7's prime. That's the only factor pair. Hey, wait a minute, I've got it. How about if this were 1 and 7 and I made this one negative instead? That works, doesn't it? No. Absolutely not. And why not? FOIL that back out completely. You will get your x squared, but -1 times -7 does not return -7 here at the end. When you check this by foiling it back out, you'll have a +7 at the end. So here's what I want to tell you about this problem. Once you've determined that your signs are opposite, you can't change that. They're opposite. I don't care what would be convenient. To get a negative here at the end, those signs have to be opposite. If your problem tells you the signs will be the same, in fact they're both whatever, then that's locked into place. You can't go messing with the signs, changing them from same to opposite or from opposite to same. The only thing you can possibly do is, in a problem like this, you could put the minus here and the plus there and try it, but that's not going to help. I'm looking for two numbers whose product is -7, whose sum is -8. There are no two such numbers. And so this is prime. The point is, once you've determined the nature of your signs, you can't change that from being opposite to same or from being same to opposite. And that is a common mistake that I see a lot of times. And it is a mistake I will quiz and test you on. You know that. So that's the AC method. What I'd like you to do is go back through these homework problems, and you can skip around. You don't have to do every single one by the AC method, but jump back around and do a handful or more, maybe every other odd. And try this AC method to get a feel for it, to get good at it, to get quick at it. Because it is handy. If you get stuck, it's a guaranteed method that will either find those factors for you or demonstrate very quickly that what you have is prime. Quickly compared to demonstrating prime through trial and error and being sure you've kept track of every different possibility. Trial and error is typically faster. Trial and error, this unfoil method we did last time, is typically faster. But AC method is guaranteed. And it's especially handy for demonstrating that a trinomial is prime. So go back and try your hand at this AC method in some of these homework problems, maybe every other odd, until you get a feel for this method.